According to Kepler's first law of planetary motion, the orbit of each planet is an ellipse, with the Sun at one of its foci. Kepler published his first law in 1609, breaking with the more than 2,000-year-old belief that orbits were perfect circles. This doctrine caused serious problems in both the geocentric Ptolemaic system and the heliocentric model put forward by Copernicus. These models assumed a complex interaction of circles in their description of the motion of celestial objects. By abandoning the idea of circular orbits in favor of elliptical orbits, the description of planetary motion was simplified. According to Kepler's second law, the line joining a planet and the Sun, the radius vector, covers equal areas during equal intervals of time. That is, at the perihelion, when the planet is near the Sun, and thus the radius vector of its orbit is shorter, it moves faster than at the aphelion. The speed of the Earth at the perihelion is 30.29 kilometers per second, while at the aphelion it is 29.29 kilometers per second. The orbit of Mercury is more eccentric. Therefore, its orbital speed is 58.98 kilometers per second at the perihelion and 38.86 kilometers per second at the aphelion. According to Kepler's third law, the square of the orbital period of a planet is directly proportional to the cube of the major axis of its orbit. This means that the orbital period of planets further from the Sun is longer. Mercury, which is the nearest planet to the Sun, has an orbital period of about 88 Earth days. The Earth's orbital period is 365 days, while that of Neptune, the outermost planet in the solar system, is more than 160 Earth years. In the formulation of Kepler's third law, semi-major axes are often used instead of major axes, but this does not change the validity of the law. Kepler's laws, which were based on data from Tycho Brahe's astronomical observations, represented the foundation of celestial mechanics. The three laws also provided a basis for Isaac Newton's theory of gravity, explaining the physics of planetary motion.